So, well, our problem was drone pathfinding for wildfire detection. And our problem was wildfires, right? They're a large problem. They cause tons of damage to people and to the environment. And they're becoming more frequent with climate change. So it's a growing issue. And while we have current systems to deal with them, they work best when fires are caught early. And if a fire is not caught early, it can become too large and it can be really difficult to deal with. Now, we have drones that could detect fires fly over forests, but they need to have efficient paths in order to do so. And because of how vast the forests are, how many different types of forests with different environments that can be very dynamic, a simple algorithm may not work very well for that, which limits their ability to find the fires quickly and efficiently.
Yeah, you can go ahead.
So the reason that we picked this problem is, as I said, wildfires are very damaging. They cause damage to both people and the ecosystem, and worsening as a result of climate change. By using drones for efficient surveys, we get an immediate solution, because of course the long-term solution would be trying to reduce climate change, reduce the frequency and severity of these fires, but you need an immediate solution because there are going to be large damaging fires now. So we have drones that can work with our current fire response to help it work quicker and more effectively.
Yep.
So our solution was to use reinforcement learning in order to train the drones to efficiently scan the whole forest. This allows them to find fires quickly and adapt to different environments, because a simple algorithm would just maybe tell the drones the path to take. But if, say, there's obstacles or wind, the drones may not effectively handle that unless they can adapt, which the AI allows them to. And it means that you don't need manual reprogramming for every new forest that you go to. For our specific case, because we don't have drones over a large forest, we use Webots, which is a robotic simulator, which gives us faster development and faster training, and should be close enough to real world physics in order to effectively train the drones. And by using reinforcement learning, it's able to adapt to forests with different situations. And also, because the way reinforcement learning works, if you have, say, a new sensor at one point, you can add a new scoring condition for that, which makes this extensible and able to grow.
Yeah.
Okay, so yeah, I have a live demonstration or through the simulation. I'll show two stages to start. First is our training stage, and of course, initially they won't work very well. You'll see the drones just fall to the ground. But if I give it just a little bit of time, even after maybe 10 seconds of training, we can see that they stay in the air a little bit longer and they cover a little more area. They don't just fall straight down. They try and get a little bit farther. And then the next stage I'll show is the actual, let me set the simulation. I'll show a pre-trained version of the drones. And with this, we'll see that they're able to cover a much larger area. I won't be able to follow them for the whole thing because it is a large area that they cover, but you can see they keep going straight. They stay in the air for a while. And if I speed this up, maybe I'll select one drone to help track it. Yeah. You can see they go pretty far and they'll keep going and keep scanning more areas.
Yeah.
So during this program, I worked on the programming of the project and also helped research. One example of the program was originally we had bugs in our drone controller. The drones wouldn't stay stable in flight. I helped fix those bugs and get it working. Of course, is also part of writing the code to get the drones training off of the simulation, and I helped tune the training values to help it train effectively. And during research, I worked with my mentor during sessions and also with my teammate to find resources and do research, learn about how the AI works and what AI is best for this. We decide on reinforcement learning. And I also, on my own, researched how to implement it, like libraries, and just how to get it working in Python with our simulation. And throughout, I think I learned a lot about reinforcement learning specifically in its applications, pathfinding being one common one. Working with actually implementing the AI, I think was helpful because I got to see like how it works, what actually makes a big impact on whether it works well or not. And also I learned how to use some AI tools under the guidance of my mentor, and stuff that's just applicable for future projects, whether it's using AI tools to develop or implementing AI. And
Got
the
it.
impact.
Yeah, please go ahead.
And as you saw, the drones were able to cover a much larger area after they trained, which would allow for, in a real world, when they're flying over forest, hopefully efficient wildfire detection. For future development, this currently uses simple scoring, using just like area covered, crash avoidance, relatively basic conditions, because we don't have a very complex environment. I don't have like a supercomputer here, so we need to work with rather simple stuff. But if we have a better environment, if we have more computational power, because the way reinforcement learning works, it's fairly easy to add a new condition to reward it. Say, I think I mentioned this, an obstacle, you could penalize it for going close to an obstacle and it would learn to avoid that. And also, this technology applies beyond just wildfire detection. Obviously, that's our focus for this specific project, but you could use robots to scan areas for many purposes, which allows us to expand a lot in the future.